Hi there, welcome up to Polish Up Your Pedagogy. This Polish Up Your Pedagogy is about using 5 and 10 frames to teach number structures. And my name is Janie Henderson and I'm part of the pedagogy team. This piece of CLPL links to the pedagogy sales. Learners progress through high quality learning opportunities to enrich knowledge, promote curiosity and develop skills for learning, life and work. And thinking about our GTC standards, it links to 3.2.1, which is about critically and effectively organising and managing learning. So why do we teach number structures? Well, Bob Wright and his colleagues, whose work sits behind our numeracy frameworks in East Lothian, says that it is critical that students' early arithmetical thinking progresses from being based on counting by ones to being based on structuring numbers. Most pupils' early arithmetical strategies are based on counting by ones. So if you present a child with the sum 7 add 6, they may solve this by counting 6 on from 7. Or they may even start at 1 and count 1, 2, 3, 4, 5, 6, 7 and then add on the 6 ones. But it's important that they develop more knowledgeable ways to add and subtract numbers. So for example, with the sum 7 add 6, could they double 6 to get 12 and then add an extra 1 to make 13? Or could they partition that 6 into 3 and 3 and do 7 add 3 to get to 10 and then 10 add 3 to get to 13? These strategies are far more sophisticated than counting by ones, and they involve thinking that's referred to as structuring numbers. We want pupils to see numbers as being constructed of smaller parts. We want them to be able to organise and reorganise them to make them easier to work with. We want learners to recognise and manipulate key number combinations and partitions and move away from just doing everything in ones. And this is where many of our children become stuck. Research has shown that the most common characteristic of low-attaining maths students is their persistent dependence on counting by ones. It seems that if they cannot structure numbers, then they are struggling to progress in numeracy. And so this video is about how we can use 5 and 10 frames as teachers to deliver high-quality teaching and learning so that learners can develop their non-count by one strategies to support their development of addition and subtraction. So today's aims of this session are to develop an understanding of how to use 5 and 10 frames to teach number structures, and also to understand where this learning sits within the new East Lothian Council numeracy frameworks, and which I can statements it relates to. Here's the numeracy progression at a glance, and you can see that addition and subtraction to 5 and 10 sits in addition and subtraction under the number structuring for addition and subtraction column in On Track in P1 and On Track in P2. If we think about an On Track in P1, it's in this column, number structures for addition and subtraction, and we start off thinking about combining and partitioning numbers to 5, and then we move on to thinking about structures to 10 and then partitioning numbers to 10 using 5. So how are we going to teach these I can statements? Well, using 5 frames and 10 frames is a perfect resource. Moving on to primary 2, addition and subtraction to 10 also sits in that number structures for addition and subtraction column. Here we focus on combining and partitioning to 5 and small doubles to 10 as we did in primary 1, but we move on to adding and subtraction within 5 and partitions of 10. And again, using 5 frames and 10 frames are the perfect manipulatives for teaching this learning. So if we want learners to be able to understand numbers and how they can be structured in different ways, then learners need to understand what combining and partitioning is. Combining and partitioning refers to those aspects of children's early number knowledge that involve small numbers and does not involve counting by ones. So if we think about combining first, if we were to ask a child, what is 2 add 2, and that child was to say 4 without counting in ones, then we could say that that child knows this combination. He or she can combine numbers. If we have a different child and we ask them to tell us 2 numbers that make 4, they may say 2 and 2, or they may say 3 and 1, then we can conclude that this child can partition 4 without counting by ones. So 5 and 10 frames can be used to teach both combining and partitioning because they are a visual tool and they allow learners to see numbers as different patterns of dots. We can use 5 frames to teach number structures within 5. 5 frame is just a series of 5 boxes and the patterns are built with dots from left to right. Here are the 5 frames that show combining numbers to 5. These can be shown to learners and then they are flashed on giant cards or on an interactive whiteboard. You would start off by showing each of those cards in turn and then you would muddle them up. You would move from showing it and discussing it to flashing it. This means that you're showing the frame, but you're only allowing the learners to see it for a short period of time. And it's up to you as the teacher to micro-adjust the speed of the flash depending on the needs of the learners. When you show and flash these frames, you're going to ask the children key questions. You're going to ask them how many dots they see, how many empty squares in each pattern, and then how many altogether. We want pupils to realise that it's the combination of dots and empty boxes that makes 5. We want learners to start visualising each of these patterns on each of these cards, rather than counting in ones. Once you've worked with showing it and flashing it, children can then start to build the patterns. They can build it on an empty 5 frame, like the one at the top of the screen. And then, as you flash the card with the combination on it, or you say the card, then they can use an empty 5 frame and build patterns with buttons or conkers or cubes or spots on a whiteboard pattern. And the teacher can ask the key questions. How many dots, how many empty squares, how many dots and empty squares altogether. Learners can then notate what they have written in different ways, maybe by using magnetic numbers or numbers written on pebbles or a dice with the number turned to show how many spots or items are in the 5 frame. Moving on to partitions of 5, here are the 5 frames that show the 6 different partitions. You can see that these versions have both red and yellow dots to show the different ways to make 5. So just as before, these can be shown first in order and then flashed, micro-adjusting the speed of the flash depending on the needs of the learners. Then, you as the teacher can ask the key questions. How many dots do you see? Well, there's 5. But in each pattern, how many red dots and how many yellow dots? Children can then build it on their empty frame as you flash it or say it. Again, building with conkers or buttons or counters, and the teacher asks the same questions as before. They can then notate what they write in different ways on whiteboards using magnetic numbers or using symbols add and equals. Thinking about mathematisation, how are we going to move children on in their learning from using the visual 5 frame? Well, we need to make sure that we distance the setting so that children can combine and partition without the 5 frame, without the materials. So we can take the visual 5 frame and we can add a screen. In this example, the red dots are screened. So we can ask the question, how many yellow dots do you see? So how many red dots are hiding under the screen to make 5? Pupils can then write down their solution. But questioning in this way also presents the problem as a missing add end or a missing number sum. So we knew there was 3, how many more to make 5? Moving on to using 10 frames. A 10 frame is just like a double 5 frame. It has 2 rows of 5. And we build dot patterns from the left-hand side just as we did on a 5 frame. There's 2 different types of 10 frames and both are equally important, but we use them to teach different things. 10 frames with a pairwise pattern have dots that are arranged in pairs from left to right. This frame on the left shows a pairwise pattern. The spots have been built in pairs. 2, then another 2, then another 2, and then a 1. So it shows the pattern for 7. Arranged as 4 on the top and 3 on the bottom, or the double 3, which is 6, and then the 1 extra lone spot, which is 7. These pairwise pattern cards are used to teach doubles or near doubles. The other set of 10 frames on the right hand side of the screen shows a 5-wise pattern. Here dots are arranged one at a time, filling up the row on the first top row and then on the bottom row. So this frame also shows 7, but it shows it as 5 on the top and 2 on the bottom. So thinking about 5-wise patterns, we use these patterns to teach 5 plus facts. 5 plus 1, 5 plus 2, 5 plus 3, 5 plus 4, and 5 plus 5. And we use them in exactly the same way as we do the 5 frames. We show them to learners and then we move to flashing them. So here is the 5-wise pattern for 6. We would ask learners how many are on the top, how many on the bottom, so how many altogether. So 5 plus 1 equals 6, or 5 add 1 equals 6. And then just as before, we would move to building and notating them. First, you would show each pattern in order. 5 plus 1, 5 plus 2, and so on. And then you would muddle them up, maybe showing 5 plus 3 first, then 5 plus 1, then 5 plus 4. Then you could mathematise them using a screen. Screen the 5 dots on the top, ask how many they see on the bottom, tell your learners that you've covered up the 5 on the top and so can they work out how many altogether. And then once they can visualise it, then they can start to build it. Firstly using the visual, and then taking away that visual, and then starting to notate it with using the visual and then without the visual. Moving on to pairwise pattern 10 frames, as I said earlier, we use these to teach doubles. We can use them in the same way that we use 5 frames. So we show them first and then we flash it. Then we can build them on an empty 10 frame and notate it as before. So when you're showing them and discussing them, you can ask the questions. How many on the top? How many on the bottom? And then how many all together? You can alter your language. So 3 add 3 equals 6, but you could also say 3 plus 3 equals 6, or 3 more than 3 is 6. Or you could put it into a problem. What would 3 chocolate buttons and 3 chocolate buttons be? Make it real, link it to word problems as part of your teaching. Initially, you're going to focus on the double and then show how that links to a near double. So the double on the left shows the double 3, but then we add one more spot to show the near double 4 and 3, which is 7. So we ask how many on the top, how many on the bottom. 4 add 3 equals 7. Finally, thinking about partitions of 10, understanding that 10 can be made in lots of ways, and seeing this visually is really important. So either using the pairwise pattern cards with the 2 colours of spots, or using the 5-wise pattern cards with the 2 colours of spots can be used to teach partitions of 10. Use the same routine, show, flash, build, notate, and ask learners how many black spots they see and how many red spots they see. Show and flash all the combinations in order and then move to muddling them up. Finally, it's important that you make your teaching active and engaging by varying your resources in the games that you use. Giant 10 frames can be made outside. You can use already made 10 frames which have been laminated and take them outside and use twigs and leaves and stones as spots. Masking tape on the carpet in your classroom or on the floor in your classroom or outside on slabs can be used to make a 10 frame, and then toys or teddies or paper plates or bought-in spots can be used to fill your 10 frame. Online 10 frames are great as a useful resource, and Numicon is perfect for teaching 10 frame work because it's actually shaped in the same way as pairwise patterns on a 10 frame. There's also the purple, green and red book with particular chapters that link to using 5 and 10 frames, and there's also the resource folder in the Numeracy drive. So thinking about the learning from today and thinking about challenge questions, how well are learners in your class enabled to select and use high quality resources for numeracy? How well does your questioning strategies enhance learners' experience? And how confident are we that all learners experience activities that are varied, that are differentiated to meet their needs, where they are active, and that provide effective support and challenge? Thanks for listening today, and if you want to contact any of us at the pedagogy team, please feel free to do so.